All right, so today we're going to talk about transformations and we're going to apply them to exponential functions. You've learned a lot about transformations with different functions, and we've always talked about your a, h, and k, okay? This time your h looks a little different because it's going to be your exponent, okay? And then you have a b that's the base, which we're not going to deal with the transformations, okay? So the three letters we're going to deal with in transformations is your a, h, and k, okay? So if h is positive, remember h is about your horizontal movements. Okay, that is your horizontal movements, left to right. All right, and remember it's opposite of what you think. So if your h is positive, you're actually going to the left. And if your h is negative, you're going to the right. Okay? Your a tells you about your stretching, reflecting, and compressing. Okay? Uh-oh. Go away. Okay. You go away too. All right. Tells you about your stretching, reflecting, and compressing. All right. Now, if A is negative, okay, I've stressed this if you've had me before. When the A is negative, it means something completely different from the stretching and compressing. And once you state this, you don't have to look at that negative again. Okay. So if A is negative, it means you have an x-axis reflect. Okay. Hope it's all coming back to you. All right. So once you've taken care of that negative, you're done. Okay. You move on to the stretching and compressing if there is any. Okay. If A is greater than 1, it is going to be a stretch. We're going to call it a vertical stretch. I spelled vertical wrong. Vertical. There we go. Vertical stretch. And then if your A is in between 0 and 1, it's a vertical compression. Do you see how it says between 0 and 1? Because it's not including those negative numbers. Okay? A compression is not a negative number. Okay? A compression is going to be your fractions like 1/2, 1/3, 1/4, 2/3. Okay? All right. Now, K is that last letter. It's everybody's favorite because it does your vertical movements. That's your up and downs. Okay? And it's the same. If K is positive, we go up. If K is negative, we go down. Okay? All right, so what we're going to do is we're going to look at a couple of exponential equations, and we're just going to state the transformations. Okay? All right. So let me get my pens ready because you know I like to color code my transformations. Let's get a purple in there. All right. So here we go. So this one. Anything that is not the parent function, and it tells me that my parent function is this, okay? So anything that is not a 2 to the x is a transformation that has been made, okay? So anything that is not the parent function is a transformation, all right? So when I look at this first one, this 2 to the x, that is your parent function. So this minus 2 up here is a transformation. And if we look back up, that's x minus 2. And when you have it, that is your h value. And minus, which is negative, means I went to the right. So we would say we went right 2. And that's it for that one. Okay? All right, next one. This is my parent function. So what is new is this minus 2. That's really not. There we go. All right, this minus 2 is new. So when I go up here, that minus 2 is going to be my k value. And it's negative, so it means I went down. So I went down 2. Okay? All right, next one. So my parent function is 2 to the x. Okay? And if you look, I've got a negative out front. Well, when my a is negative, okay, because there's an understood -1 there, but they're not going to write a -1 there. Okay, it's going to be a negative. But it is saying your A is -1. Okay, and if your A is negative, it's an x-axis reflect. So that is an x-axis reflect. And if you look, I've got another one, a +3. Well, if -2 means down 2, then a +3 is going to mean up 3. Okay, so all you're doing is stating, because if it ever tells you to graph, Just Most can graph it for you. Okay, it's on the exam now. So don't worry about that. So if it said to graph these, which it doesn't, okay, then you can just use Desmos, okay? All right, so next row, here we go. Our parent function is 2 to the x. So I have a plus 2 up top. That's my h value, and when your h is positive, you go left. So that's going to mean left 2, okay? Then I've got a minus 3 at the end, and that minus 3 means I went down 3. Okay? All right, let's keep chugging. So I've got another 2 to the x. Now you could have 3 to the x, you could have 4 to the x, okay? But that base in that x is always going to be part of your parent function, no matter what your parent function is, okay? All right, so I have a minus 4 up here. Plus 2 means left 2, then a minus 4 is going to mean right 4. And then I've got a plus 3, which is opposite of over here, so it means I'm going to go up 3, okay? All right, now over here I've got an a value that's not 1, but I have a negative. That negative means x-axis reflect. And once you write that, we do not care about that negative number anymore. Like, not at all do we care about that negative number, okay? You've named it, you're done, we're moving on, okay? Because this 2 right here, that is your a value. Okay, by itself, that is your a value. Not with the negative, not with the base. It is by itself, okay? And that actually brings up another point. Do you see the difference between this problem and this problem? That 2 is the base. This 2 is the base. Do not get it confused. That's the biggest mistake I saw with transformations with exponentials last year, was that they got the a value mixed up with the b value. You're always going to have a b value, but you're not always going to have an a value, okay? So like in this problem right here, okay, right here, this guy, you see him? He did not have an a value. That is the base. So I didn't write a vertical stretch or a vertical compression, okay? But over here, there is an a value and there is a base. Okay, so please do not get your base and your a values confused. That's the biggest mistake you'll probably make on this one. Okay, so pay attention to it being separate. So this a value is 2. Okay, so when I come up here, when my a value is greater than 1, it's a vertical stretch. So we would say, we're just going to say a VS by 2. Okay, all right, last row. That's why I'm highlighting the base here, the parent function. So if you like highlight, box in something with the base, mark it out. We don't need it for transformations. Okay, do something that separates that base from your a value so you don't call it your a value. Okay, all right, so again, I have a negative. Okay, so I need to take care of that negative. All right, that negative right there means an x-axis reflect, okay? And then that 3 means something totally different, okay? That 3 is your a value, okay? That's my a value. It's greater than 1, so we're going to say it's a vertical stretch by 3, okay? And then we get to our left, right, ups, downs, okay? So this minus 4 up here, that's going to be a right 4, had a brain lock for a minute, and then the minus 3 is going to be your down 3. Okay, so that one had all the above, and that's fine. Sometimes they can have 1 transformation, sometimes they can have 6. I think they can have 6, probably. You know, I'm just being dramatic, okay, but it doesn't always have to have the same amount of transformations, okay, is what I'm trying to say. If you don't have an a value, that's fine. Keep booking, okay? All right, so next one, highlight that base. Get in the habit of that. If it's confusing you, highlight the base, okay? Everything's electronic now. You can get your tools and go for it. Y'all probably work this stuff way better than I do. So this negative means x-axis reflect, okay? And then that minus 9 up here, the tiny 9, that means right 9. And that's it for that guy. Okay? All right, last one we're going to do together. So I'm highlighting the base. Okay? So if you look, I have an A value here. Here's my A value. That number is less than 1 but greater than 0. So that's going to be a vertical compression by 1/2. Okay? And then that last number over there, it's going to mean you're down 4. Okay? So I hope this helps you guys with transformations with exponential. We'll do transformations with logs tomorrow. And you have an assignment. Bye, guys.